Hi guys, so in this let's talk about how adjacent channel interference can cause excessive L2 retransmissions, right? So ACI, let me just quickly change the pen width to a little less than this. Okay, yeah, so how ACI will cause excessive layer 2 retransmission is what we are trying to figure out from this, and what can we do to fix that problem. Okay, yeah, so in the Wi-Fi industry, in the WLAN industry, the channel which is previously numbered or the channel that is next in numbered is an adjacent channel. Okay, so let's say it's 1611 are non-overlapping channels in 2.4. So channel number 2, 7 and 10 and then 12, they are adjacent channels to these channels right there. Okay, the reason why these channels are used, that is 1, 6 and 11, are because their frequencies are non-overlapping. Okay, so always remember this: 1, 6, 11 are non-overlapping channels in 2.4 gigahertz spectrum. Channel number 1, channel number 6 and channel number 11. This is just a representation: 1, 6 and 11. Other channels are basically channel number 1, 2, 3, 4, 5 are all overlapping channels, and then again, so 1 and 6 are non-overlapping, 2 and 7 are non-overlapping, 3 and 8 are non-overlapping, 4 and 9 are non-overlapping channels, right? Because there's enough gap in the frequency. Again, so 2.4 spectrum is from 2.401 gigahertz all the way to 2.473 gigahertz, which gives us 72 megahertz of band to send traffic, and all these 1 to 11 channels are in this 72 megahertz band. That is why we only have 3 non-overlapping channels in the entire 72 megahertz band, as compared to the 5 gigahertz band, where there are 23 to 24 channels which are all non-overlapping. Okay, anyway, yeah, so when you design a network, let's say there is a coverage like this, like this, like this, and then like this, and then like this. That's pretty much how network is designed. So let's say these are all APs working on 1, 6, 11, and then 11. Let's say 1, let's say 6. This is how the channel schema really works. Okay. Now it's very important that you have enough overlap of the coverage cells, right? So these are all BSS coverage cells: 1 and 2 and 3 and 4 and 5 and 6. There has to be enough overlap of the coverage cells so that roaming can happen properly, correct? If there's not enough coverage overlap, then the client will really drop and the roaming will not happen at all. That's why you need enough coverage overlap of the cells, but that side channel should not be on the of that overlapping frequency. The frequency should be non-overlapping, right? That's when you're not going to have ACI. That's when you're not in this scenario. ACI will not happen in a way, right? Now if you have something like this, if the design is not good, the channel schema is not properly done, and there is some sort of a coverage overlap, let's say this channel number 1, and then there is another for example, let's say channel number 4 here used, and then maybe 8 here used, but 7 here used, or whatever, something like this. In this scenario you will see ACI. There is an overlap of the coverage cell and an overlap of the frequency also. Okay, when this is happening, what will happen is one thing: the data will get corrupted. Okay, and when the data gets corrupted, the destination will not send an ACK. When an ACK is not sent, the frame needs to be retransmitted, correct? And that's how high ACI in a network is going to cause high L2 retries. Okay, now what can be done to fix this? It's a very simple thing. Anywhere, and recently I found this in one of the networks I was working in. Okay, there was a manual channel setting done. By default it's going to take 1611 if you run any vendor in the market right now. By default on 2.4 they're going to select 1, 6 and 11. But there was a network in one of the customers location. In fact, it's a factory, in a warehouse, in a manufacturing plant, sorry, where I saw that manually they had made changes to this, and instead of automatically they had set the channel schema to manual, and they had selected 1, 4, 7 and 9, something like that. These 4 channels were used, I think. Anyway, so this was causing high ACI, and this was causing very high layer 2 retries, and that's the reason why anyway the data was getting corrupted. The destination could not send an ACK because it could not decode the message, and hence the retransmissions were happening, which was bringing down the entire performance of the network, right? So that's the reason why you should always have the design done right. Make sure the design is done right. The channel schema used is pretty much, nowadays RRM takes care of it. Set it to automatic. Do not play with it. Do not set it to manual unless you know what you're doing. Okay, I would set it to automatic all the time, and by default they'll select 1, 6, 11 in 2.4. Now the good thing is on 5 gigahertz every channel is non-overlapping, so it's pretty much whatever you select, set it to automatic, all the channels are non-overlapping. So even if it's 52, 48, 40, 44, 40, all of them are non-overlapping. You can have a schema like this in 5 gigahertz where this can be 40, this can be 36, this can be 44, this can be 48, and this can be 52. Everything is fine because they're all anyway non-overlapping, right? So anyway, this is what ACI is, and which causes a lot of data corruption and a lot of retransmissions in the layer 2 network, and that's pretty much what you should do to fix the ACI problem in the network, right? So in the next video we'll talk about the next cause of high retries, and see you in the next video. Thank you.